Hello and welcome to the What's New series for Decision Space 10ep5 series. My name is Colin Melvin and I am the product owner and your presenter for DSG's Geophysical Interpretation module.
This What's New video shows functionality for this current release, but I will also go through the functionality introduced since 10ep5 as a review in case you've upgraded from 10ep4. I'll start with 10ep5.0, but if you are just interested in this current release, you can skip ahead to that time in the video listed here.
Let's look at all of the new functionality in 10ep5.0 for geophysical interpretation. This outline shows a lot of new functionality 10ep5 introduces into DS geophysical interpretation. Most noteworthy is the support for multi-Z horizons, but not to be forgotten are many ways to switch horizon displays. I will go over each of these features in the following slides. The first new feature in DSG 10ep5 is the ability to display a horizon in the map editor as a solid color as opposed to a multicolor surface. You set this option in the Horizon Display Properties editor. We brought back a SizeWorks feature in that the active horizon you are interpreting now turns a different color. Usually the horizon turns yellow just like in SizeWorks, but you have the option to change the color. This highlighting the active horizon makes it clearer which horizon you are interpreting so that you don't unintendedly interpret the wrong horizon and have to undo mistakes. We'll get up close and personal with multi-Z in a moment, but I want to show another option in the Horizon Display Property Editor that applies to both single Z and multi-Z horizons. And that option is the ability to display an instantaneous amplitude extraction and overlay it on the horizon by simply changing the display properties on the horizon. Hence, you don't have to spend the time to set up and run an attributes calculation if you only want a quick peek at the structural amplitudes. The cube view now has a patch delete that is similar to the map editor's horizon polygon delete. It's a little different that you select a patch of the horizon instead of drawing a 2D polygon, but the results are the same either way. Multi-Z is the star feature of 10ep5, and there are a lot of utilities that complement it. I want to start off not with how to create a multi-Z horizon outright, but rather how to take your existing horizons that you have represented one surface and combine them into a single multi-Z horizon. Under the Utilities menu, you will find the multi-Z horizon converter. In this converter, you select your horizons to combine. If needed, you may change the order of the horizons to adjust to correct the stratigraphic and structural order. This utility saves you a lot of time as you don't need to reinterpret and retrack your existing horizons to make them a multi-Z horizon. Of course, the multi-Z functionality allows the interpretation of multiple layers in a single horizon. As you might expect, this shines in fields with thrust faults, overturned structures, and salt bodies. While interpreting them is very similar to interpreting a single Z horizon, except for creating additional layers, the multi-Z horizons come with extra options throughout DSG. I mentioned the quick amplitude extraction before in Display Properties Editor. For multi-Z, the color map can also show the thickness between layers. The multi-Z layer option allows you to control which layers the editors display. For example, the active option will only display the layer you are currently interpreting. The other options allow you to create a list of which layers to display and hide. The slicing mode displays one layer and allows you to scroll through them layer by layer with a numerical counter. Creating a multi-Z horizon is similar to creating a single Z horizon, with the added step of clicking a checkbox to distinguish the horizon as a multi-Z. With that option on, the multi-Z layer table allows you to create each layer as needed. Each layer interprets and auto-tracks like a single Z horizon. If you look at this example, the geoscientist created 5 layers in one multi-Z horizon to characterize the salt bodies. One tracks the top of the salt, another the base of the salt, and the other 3 track the sides. This was done so that there was control for each side of the salt body in case the interpreter needed to change one part of the body without changing too much of the other four. Also, splitting the layers like this gives access to the multi-Z utility in case of the need to split the layers into a single Z horizons to export out of DSG to partners. To QC the shape of the structure, the geoscientist turned on the fill option so that multi-Z will highlight the inside of the salt canopy. This interpreter also made sure to interpret each layer a little bit beyond an intersection to get a complete salt body. And lastly, they were also wise to check the auto trim option to clean up the surfaces so it doesn't look like the salt body has straggly lines at each corner. Multi-Z is not just for structural mapping. It has its uses in QI. In this case, the attributes analyst created a multi-Z horizon where each horizon is an interpretation on different partial offset stacks. With this kind of an interpretation, the display properties editor can uniformly set the color bar across all three layers in the multi-Z horizon in one option. What used to be three separate color bar setups for comparing near, mid, and far offset amplitude extractions is now a single setup. And these are the main geophysical interpretation functionalities for 10ep5.0. If you want more information about these features, plus information on fixed defects, I suggest reading the release notes. DSG 10ep5.2 Geophysical Interpretation introduces new functionality in attribute displays and horizon interpretation. Let's take a look at them. DS Geophysical Interpretation introduces 4 new features, which are balancing controls for the cube view RGB blending, extending the horizon overview to the map editor, a polar diagram for multi-azimuth data, and a spline interpolation option for interpreting horizons. RGB blending for the cube editor now includes weighting parameters in the case where one of the components is not scaled correctly. This feature can correct for unusual dark blending when the volume combination is biased towards one of the volumes. If the weighting doesn't work, then you can also change the minimum and maximum values of each input. In this example, the default loaded volumes that would otherwise create a very dark and pointless attribute cube now distinguishes the faults, plus a potential channel at the southeast corner of the seismic volume. In previous releases, the overlay for horizons was exclusive to the cube editor. This functionality is now available in the map editors. Simply go into the display properties editor for the horizon and select an attribute to overlay. In this case, I am displaying the velocity along a dipping and faulted structural surface so that I can look for velocity anomalies and trends compared to the structural layer. For those of you who work with multi-azimuth data, we've added a new polar chart to help quickly analyze azimuthal and angle changes within the seismic. If your seismic data set does not contain azimuth and angle keywords, you can set the data's associated azimuth and angle ranges yourself. Once set, clicking on an azimuth angle wedge in the polar chart immediately displays the associated seismic in the section view. This enables you to quickly analyze azimuthal-based and angle-based changes in your seismic amplitudes. Changes in azimuthal amplitude tend to indicate the orientation of fractures and regional stresses, while angle amplitude changes tend to indicate changes in fluids or changes in lithology. For horizon interpretations, point-to-point mode now supports spline interpolation to make your surfaces more geologically plausible. When in spline interpolation mode, instead of picking endpoints, you now pick apexes and inflection points to get a smooth curve. In this example, you can see the major differences between the curved spline and the hairpin turn from the traditional point-to-point interpretation. You control the percentage of curvature with the interpolation parameter, which ranges from 0.1 to 1. 1 is a very curvy spline, almost like a French curve. 0.1 is almost like a point-to-point line with a tight curve at each turn. Spline interpolation is great when you have data that can't be auto-tracked, the structure is complex, and you want to create a geologically reasonable surface without repetitive strain injuries of interpreting trace by trace to get a nonlinear geologic structural interpretation. And that covers the main features in 10ep5.2 for DSG physical interpretation. For more information about any of these features, including any fix for defects, consult the release notes. 10ep5.3's theme is workflow efficiency, streamlining, and performance. One major feature captures this theme. That major feature is the chaining process in seismic attribute generation. Prior to this release, seismic attribute generation required running processes one at a time. To run multiple processes involved iterations of changing the output to the input and creating a new output. For a long post-back workflow, that's a lot of changes at each intermediate step. And as anyone who has run seismic attributes this way for more than an hour can attest that they made a mistake by setting the wrong input or lost track of which data was what. And additionally, changing one parameter a step or two back meant repeating the whole process over again. Suffice to say that parameter testing is painful. The new Flow Manager relieves you of that bookkeeping pain. Similar to the workflow chaining in the classic post-stack PAL, the Flow Manager collects sequential processes and runs all of them in a single button click. It operates on both 3D and 2D. Using the Flow Manager starts with parameterizing processes as you normally would in seismic attribute generation. Instead of calculating the attribute or processes at this point, you add the process to the Flow Manager. It's a good idea to have the Flow Manager open to see what is being added. That way, you can confirm the parameters set or make a change before running the processing job. That also applies to the sequential order that the flow will run in. Once the order is prepared and ready, it takes a single push of the Run Flow button to send the flow to the Job Manager. It's at this point that you can now relish in the time savings of letting Flow Manager run through your workflow. Go grab yourself a cup of coffee or tea, maybe lunch if you're hungry, attend a meeting, or if nothing else, listen to another one of our great What's New videos while you wait. Notice that the Job Manager lists out each step of the workflow. This allows you to see what step the processing is on. If the job fails, you'll have an idea of which step to troubleshoot. The Flow Manager creates temporary data at each step, which serves two purposes. It gives the processor a QC on each step while also serving as a point to restart a failed workflow or parameter test. While these temporary data are available while the job is running, the final product is the only data saved to the session. The Flow Manager can also save and restore all of the workflow parameters. While you're free to save the chain workflows anywhere you wish, the default location is in the dir.dat path, so that backing up the OpenWorks project will preserve the workflows in the project archive. Now, chain workflows is the big efficiency and time saver in this release, but there are other minor fixes we made along the way, which you can look up in the release notes for 10ep5.3. That covers the main new features for this release of DSG Physical Interpretation. For more information for any of the fixes or features, consult the release notes. I'd like to credit those who gave us permission to show the data in this presentation, notably Equinor and the Valve license partners for their use of their data. I hope you learned something from this video and that you enjoy using the new features for your subsurface reservoir modeling as much as we enjoyed creating them for you. If you have any other questions regarding the new features, please reach out to Landmark Support or send me an email to colin.melvin@halliburton.com. That's colin.melvin@halliburton.com. I'll sign off by saying, remember that seismic data is black and white, but it's up to you to give it the color to make it meaningful. Until next time, I remain your product owner, Colin Melvin. Best of luck to you.